Okay, networking devices. We're going to cover LANs, MANs, and WAN devices. Of course, there's the repeater, like I mentioned before. Basically what that does is it grabs the electric signal and then just reproduces it. This is what fights attenuation. So if you get to a certain length, you put a repeater in, then whatever signal it gets, it basically amplifies it. There's a hub, which is a multi-port repeater. There's a bridge, then a switch, then a router. Okay, repeater characteristics. They work at the physical layer, layer 1. Extends the network by amplifying the signal. Helps with signal attenuation. There is no intelligence with the device. So basically what it does is goes from port 1 to port 2 and then just amplifies it. Hub characteristics. Works at the physical layer. Connects several systems to a device. Again, multi-port repeater. All data is broadcast to all ports. And there is no intelligence, no routing, no forwarding decisions or whatnot. The funny thing about a lot of the hubs is that it's very difficult to get a hub nowadays because almost everything's switched. However, with a lot of the SOHO switches, you can force them into hub mode just by doing like a Mac Storm or sometimes even playing around with the firmware or whatnot. Okay, bridge characteristics. Mainly functionality is the data link layer. This can work between the data link and transport layers. It extends a LAN by connecting similar or dissimilar LANs. Basically, it does have filtering capabilities. It forwards frames based on MAC addresses. It does not forward collision data and forwards broadcast data. So one of the primary things to know about the bridge is what layer it's going to work on, which is going to be your data link layer, and it deals with MAC and forwards broadcast. And also prevents collision domains. Okay, switch characteristic. Transfer a connection from one circuit to another circuit. It's faster than most bridges and routers because instructions are working at silicon level. Makes forwarding decisions based on MAC address. And a major functionality takes place at the data link layer. So again, it has what's called the ARP table. And the ARP table relates what MAC address and IP address is going to be there, along with what port it's associated with. So when basically somebody's trying to get to a server or file server, it goes to the switch, and the switch only reproduces that data on the specific port, unless it has a span port. And then a lot of more advanced switches allow you to basically make that one port and make that one port seem like a hub. So all the traffic going all the other ports gets pushed to that span port. Okay, VLAN. This is the virtual LAN. Logical containers use groups and users, systems, and resources and so forth. Allows administrators to not be restricted purely by the physical location. Each VLAN can have its own security policy and used in switches. Basically makes it to where you can have these specific ports, let's say ports 1 through 8, be able to communicate back and forth together, and ports 9 through 16 can communicate together, but they can't communicate within each other. For example, VLAN 1 may not be able to communicate with VLAN 2. Some of the more advanced switches outside the test, unless they specifically say layer 3 switch, will be able to route traffic between like VLAN 1 to VLAN 2. But if you are trying to jump VLANs, you usually have to have some sort of routing device because it's doing a virtual segmentation on the physical switch. Okay, router characteristics. This works at the network layer. It can connect similar or different networks, blocks broadcast and collision data. It uses routing table to make decisions based on path of packets based on their IP address, not their MAC address, like switch. This can also work as a packet filtering firewall. Again, use of control lists. And if they do mention the term firewall, like I mentioned before, it's probably going to be at the lowest level layer, which is probably going to be a stateless, which when it comes down to it, same type of scenario as a router with an ACL. Okay, gateway characteristics. Usually a device running software that connects and translates different protocols or software formats. There are several types. For example, a mail gateway, which would allow different mail applications to communicate. There's data gateways, which allows for heterogeneous clients and servers to communicate. Then security gateways, such as firewalls and perimeter security devices. Okay, Bastion host. This is a hardened system. At a minimum, it should be disable all unnecessary accounts. So it's basically a computer system with multiple NICs in it. Disable unnecessary services, subsystems, remove administration tools, and keep up to date on patches and fixes. and all systems in the DMZ should be Bastion hosts. The main reason why they're saying that is that whenever you get into the system, it's going to be at a minimum level. There's going to be less things to attack on it. Okay, firewall types. These definitely need to memorize. Generation 1 is going to be a packet filtering firewall. 2 is going to be your basic proxy. 3 is a stateful. 4 is a dynamic packet filtering. And then 5 is kernel proxy. So again, if they say the term firewall, they're primarily going to be looking at the packet filtering, which is a router with an ACL when it comes down to it. But if they go through the definitions of what generation they are, these numbers are actually important. Okay, packet filtering characteristics. Basically, simple and least expensive type of firewall. It screens hosts through an ACL, which would be allowing, for example, any, which would be any protocol from any IP address, and then potentially any port into the network to, let's say, a specific subnet using any port, any protocol, or whatnot. So when it comes down to it, again, it's referred to as a layer 3 device. It cannot keep state information connections. It's just saying I'm allowing this traffic through because it's specifically allowed, or ways to bypass that from an attacker standpoint is you pretend a connection's already been connected from the inside out and then bypass it through your basic standards or RFC issues.
Is the generation basically based on a timeline, like first generation to fifth? Is it oldest to newest technology?
On a technicality, yes, but they want you to know as far as the technology, because there's some times where you would, the majority of them are going to be stateful firewalls now, but there are times you may need a kernel proxy versus a stateful firewall, because most of the time basic stateful firewalls, all you really need is to make sure that your ACL is in place and people from the outside are not coming in through nefarious means by breaking the standards within the TCP/IP flags. Some of the flags that can break the standards are going to be just sending in your FIN flag. You turn that bit on. There's sometimes also the Christmas scan, which is traditionally going to be your FIN, your urge, and then your push. Sometimes you'll see Christmas scans with all flags turned on. There's also your null scan, which breaks the RFC standard, which are no flags are turned on. So none of the items are there. And then sometimes you'll have it to where you just send an ACK or a SYNAC, and then it sometimes can trick the firewall or router or whatnot into thinking that somebody sent a SYN out and you're responding back with that corresponding SYNAC. And if you do that, what ends up happening is the other system should respond back with a packet saying, I didn't do anything, for example, like an RST, and also give you some sort of IPID number. Okay, packet filtering, again, first generation firewall. It's going to be based off ACLs, very similar to a router. Okay, circuit level proxy makes access decisions based on network and transport layer header information, similar to packet filter, but this is not an application or protocol dependent. It provides more protection than packet filter, but less than other types. There's also SOX is the most used circuit level proxy today. The application proxy, or application level proxy. This is, makes access decisions based on data payload information or protocol information. Also must understand the command structure of the protocol. It provides a high level of protection and requires a lot of resources and performance issues. How many people here have heard of CGI proxies before? CGI proxies, basically server-side code proxies. Some people would even use Google Translator as a CGI proxy. So basically what that means is that you'd have a, say, a firewall. Somebody has a proxy on the inside saying that you can't go to specific websites, but they would allow you access to a specific, like Google Translator. So what you'd end up doing is you would bypass the security setup on the network by going to Google Translator and then translating a page that you know is going to be in Spanish. Once you translate that page, take the URL out of the parts that's going to the Spanish site that's being translated out, and then put in the site that you want to be translated. And so whenever it goes to try to do the Spanish to English translation on a specific site, it doesn't see any Spanish, it only sees English, and does the English to English translation, and just allows you to see the page. So what's ended up happening is that their site is downloading all the content for you, or their application or their page, and then re-representing it back to the user through the firewall. So some people bypass, like for example, like good old Blue Coat or some of the other proxy servers by going to CGI proxies. And a lot of, I believe Blue Coat does now, specifically they see Google as a CGI proxy and usually will block that as well. Okay, stateful firewall characteristics. Basically makes access decisions based upon the following information, such as IP address, protocol commands, a historical comparison with previous sent packets, which is going to be a time scenario, and then the condition and content of the packets. So it uses a state engine and creates and maintains a state table, which again is going to be timed. So if you connect to a system and then come back to it a day later, the state table should have basically gone through and done garbage collection and removed that data. So you shouldn't be able to come back into a network just because you were able to communicate with them a year before. Okay, it can monitor connection-oriented and connectionless protocols, and this is your third generation firewall. Okay, dynamic packet filtering. Combination of application proxies and stateful inspection firewalls. Dynamic changes, filtering rules basically based on several different factors. And this is going to be your reactive to pre-designed changes and situations. Fourth generation. Firewall placement. Considerations. Basically segments, internal network subnets, and sections to enforce security policy. Sets a choke point, and also you can use two of them to create a DMZ. And again, what that basically means, DMZ or screen subnet, is where you're going to have one firewall protecting one network from an untrusted, and then you may have a secondary firewall that's going to protect your trusted network from the half-trusted network, your DMZ. Okay, screened host definition. This is usually configuration as a router, filtering for a firewall, reduces the amount of traffic for the firewall, and then also you have screening devices, which is a filtering router, and then screened host, which is a firewall. Why would you want to use or what type of scenarios would you use a router to filter out traffic for a firewall? Yeah, if it's just basic ACLs, at this point you'd be using the router as a Generation 1 firewall. Yeah. So you're basically saying anybody coming from this IP block, just don't let them in, like the old Russian business network IP address range. And so it doesn't even bother the firewall, so it doesn't have to deal with what protocols it is. For example, if it's a fourth generation firewall that you're dealing with or whatnot. Okay, multi or dual homed. Basically, the description is you have two or more interfaces, one for each network, and this allows for one firewall to create more than one DMZ. Forwarding and routing needs to be turned off. Okay, screen subnet. Basically, it's a buffer zone is created by implementing two routers or two firewalls. Basically, creation of a single DMZ, and you can have multiple screen subnets or multiple DMZs chained together, or basically in the star configuration, where you can have multiple screen subnets, for example, VPN users, one for your wireless, one for your dial-up if you have any, and then one directly for your web servers before it gets to the network or internet. Okay, dial-up protocols and authentication protocols. In dial-up, you have SLIP and PPP. How many people remember good old SLIP or PPP? Definitely a fun one to play with, especially if you were on the good old Linux boxes way back when. Okay, there's PAP, which is Password Authentication Protocol. There's CHAP, which is Challenge Handshake Authentication Protocol. And EAP, Extensible Authentication Protocol. And then SLIP, this is Serial Line Internet Protocol. First encapsulates the protocol used to move the IP data over serial lines. Then largely replaced by PPP. And PPP's advantage over SLIP is the header and the data compression, increased performance, packet sequencing, and system does not require IP to share the connection setup process. And also there's more authentication features in PPP than SLIP. Okay, PPP, basically full duplex. What is the difference between single duplex or half duplex and full duplex?
Half is one way, whether it's going out or coming in, and full duplex is going both ways at the same time.
Yes. So a lot of times you'll see it to where networks, if they're having a lot of collisions, sometimes people dump it down to half duplex, and it gets rid of a lot of the data damage. That usually means there's something really wrong with the network, especially in today's technology. But yeah, if you have full duplex, you're going to have a lot faster throughput back and forth because it's a two-way channel. Okay, with the full duplex protocol, it moves TCP data over the synchronous and asynchronous links, and encapsulation protocol. Basically, authentication mechanisms would be the PAP, CHAP, and EAP. Okay, password authentication protocol uses authentication to remote users. It can be an authentication piece of a PPP connection, and credentials are sent in clear text. This is vulnerable to sniffing, man in the middle, and replay attacks. CHAP can be used to authenticate when in PPP. It's sent through a challenge to the client, and a client uses the user's password to encrypt the challenge, and then periodically sends the challenge to protect against man in the middle. And EAP, this allows for modular authentication protocols to be plugged in and give the company more flexibility. Basically provides a framework for several different authentication methods, such as the password, challenge response, and PKI, Kerberos, and so forth. And developed for PPP connections, but is now used in a lot of LAN and wireless, or WLAN as well. And so, for example, if you again look at Backtrack, you'll see some EAP crackers and Leap as well. Leap is going to be used more in the Cisco side, which is a lightweight EAP. Okay, VPNs, a couple different types. There's, of course, the tunneling protocols, your PPTP and your L2TP, and then, of course, your IPsec. The PPTP is still sometimes used, but that's the older one. The more common ones being pushed is the L2TP. PPTP, encapsulate protocol, used more for end-to-end VPNs instead of gateway VPNs, and works only over IP traffic. Layer 2 tunneling protocol basically combines Layer 2 forwarding and PPTP. Can provide VPNs over WLANs, and then works at the data link layer. Cannot encrypt data. Requires IPsec for security. IPsec. This provides network layer and protection, used for gateway-to-gateway VPNs. Provides authentication, integrity, and confidentiality. And the reason it does that is because of the encryption portion. It only works over IP, is becoming the de facto VPN standard. Okay, and again, VPNs, as far as IPsec is concerned, that's going to be a heavy hitter because it's going to be cross-domain. It's going to be both the crypto, and it's also going to be the telecommunications. So definitely spend some time as far as like the EA headers, things like that, or H headers. Know the difference between like the PPTP, L2TP, and why or when you would use a IPsec VPN versus an SSL VPN. So what would be a scenario that you would use an SSL VPN?
The environment you're in won't necessarily let you connect out over IPsec.
Yep. Then also a lot of people basically just do their terminal server, do a SSL VPN over that. I know a lot of individuals will try to, of course, your SSH, so they can do tunneling and do all their command line utilities there. So yeah, usually it's a lot less overhead, and sometimes the hardware will not allow you, or the environment will not allow you to do specific communications through like IPsec. Sometimes you may come across that in networks as well, such as like wireless hotel networks. A lot of the cyber cafes, of course, airports. I've been blocked several times doing VPNs in an airport. Okay, network services. DNS. We're also going to do NAT. Does everybody know what DNS is? We're pretty comfortable with that? DNS being your domain name service. What protocols and what ports does DNS use?
UDP and TCP, both port 53.
That's correct. That's something that pretty much you need to commit to memory as well. You may come across that. Basically, 53 is the ports that DNS is going to use. For your basic communications back and forth, like doing an NS lookup or a small query, that is usually going to use UDP. But if it's a large query, it's going to jump up to TCP. If it's a zone transfer, that's going to be TCP. So that's one of the few protocols that uses both TCP and UDP. Is everybody comfortable with the connectionless versus connection full communications? Like TCP basically guarantees the communication back and forth. In TCP, if it doesn't get the packet, then it basically asks for a resend. That's why some of the sequence numbers are off or whatnot. Packet numbers may be off, and it has to go back with the sequence number. And then with UDP, it's basically a fire and forget. So as soon as you get connected, then the system is going to just start dumping the data to you. Hopefully you'll get it. I know a lot of people will be playing some of those massive multiplayer online games or even just some first-person shooters. And especially if you are sniffing the network where one of your gaming consoles is going to be connected to, you're going to see a lot of UDP traffic going over the wire. And that's basically giving coordinates back to the server of where the individual character is going to be at, like the speed, the health, and all that fun stuff. I have seen scenarios to where individuals would DOS attack themselves. So what they'd end up doing is they'd have a device that's doing that, their good old Soho router, and they'd be playing a massive multi-line game, and they would want to save time. So instead of spending an hour trying to go around a ravine or something similar to that, what they would do is they would start going really fast right at this big crevice. They'd start DOS attacking their Soho router, seeing the UDP packets and whatnot. It's barely sending anything. And what the program on the other side would do is the math of where the person was and where the person's supposed to be. And as long as you didn't DOS yourself too often or too much, what ended up happening is your character would start to fly over the ravine. So they were trying to kibosh that a little bit. But then as soon as you're basically, the mathematics would have you over there, you'd stop DOSing it, and then your character would magically appear there. But that was basically off UDP. Because if it's TCP, as soon as you start DOS attacking your own system or your own network connection, it's going to say, I don't get it, and then boot you out of the game, or lock up, or log you out. So a lot of the programs that you're going to be using now do use UDP because so much data is going back and forth within the environment. I know video and audio, same thing. If anybody does any voice chat, how many people here use like Yahoo Messenger or specifically Microsoft MSN, Instant Messenger? That uses UDP. So if you're doing sniffing or an investigation in that aspect, you can actually grab all the UDP packets going from one IP to another IP and then rebuild them if you have the proper codec. But again, it doesn't matter if several of the packets get lost. It's one of the scenarios to where it gets most of it there, fire and forget, it's happy. Okay, DNS. It's a domain name service. Works within a hierarchical naming structure. Basically a host name to IP address mapping. And DNS server holds the records for the zones, things like that for the authoritative DNS server as well. And also has it to where there's MX records, which are going to be your mail records. It has records for NS, which are name server records for the domain, and also has what's called A records. Does anybody know what an A record is, a DNS?
It's usually the main, it holds like the .mils, it holds like the first,
Yeah, subdomain, yeah.
the subdomain, which is .mil.com, .org, it holds all those records.
Yeah, so for example, if you have imatarget.com or .mil or .org, you're going to have that main domain name, and then there's going to be an IP address associated with that main domain name. And then you may say like payroll.domain name, and that payroll is going to be associated with an IP address through an A record. And then if that's also going to be an email server, then you'd also have to insert an MX record pointing to that A record, or that IP address that's associated with the A record. When you're doing a zone transfer, you get all that kind of information, which is a beautiful thing from an attacker perspective, because if you do an NS lookup on a domain and it only has, say, 2 NS records, 2 mail servers, and 1 or 2 subdomains associated with it, but if you're allowed to do a zone transfer, sometimes you can see literally hundreds, if not thousands, of subdomains or other comment information, because people say that, okay, these 25 domains are actually at this town, at this building, so forth, and these are this administration contact for this geographic location. There's a lot of useful information you can get from zone transfer. However, it's less and less likely that that's going to be available to the attacker because the majority of DNS administrators are starting to block that type of transfer from going out to the network or out to the internet. And you can usually just block that by disallowing port 53 queries from the internet. Okay, NAT, Network Address Translation, invented because public IP address space was running out. Basically allows companies to use free private IP addresses. These are going to be your 10 network. It's like 10.0.0.0/8. You're going to have your 192.168.0.0 network. Then you're also going to have your 172.16.0.0 to 172.31.255.255. Those are your non-routable private IP ranges. And like I mentioned before, technically they are routable now with variable net subnetting and all that. But they are specifically segregated from the rest of the internet space and no longer allowed to be used. So if you use any of those, nobody else should be able to touch you from outside your network. There's NAT converts the private IP address to a public IP address and vice versa, and basically acts as a proxy server. So you have your NAT device and you have all of your routable or non-routable IP addresses. It hits that main device and it has a state table on all the traffic that went from your IP address to another specific IP address. It usually ends up ripping that stuff out, putting its own information on there, and then sends it out to the target. So the target server, or the person that you're trying to communicate with, only sees the IP address of the NAT box on there. And then when it comes back to the NAT box, it then goes back to you and reforwards. Okay, it has static mapping, a one-to-one relationship, and dynamic mapping. First come, first serve. It has port address translation, or PAT. One IP address is used for all hosts. An older term is hiding NAT. Okay, technologies. Good old man, Metropolitan Area Networks. The FDDIs, or Fiber Distributed Data Interface, and then SONET, Synchronous Optical Networks. FDDI, this is a token passing. It's a media cross method. There's 2 rings, and these are used for fault tolerance. So it's definitely important to know that FDDI uses 2 rings. Can operate at 100 megabits. Up to 200 megabits of both rings are used to transmit. And there's also CDDI, which is Copper Distributed Data Interface. Same as FDDI, but runs over copper wires or UDP. Cannot get the same distance as FDDI. Does anybody know why? Yep. The attenuation on copper is a lot more than on fiber. So, okay, SONET, Synchronous Optical Network. It's a physical layer standard used by the telecommunications companies. It's a dual ring and self-healing if the line should go down. And optical carrier ring. Basically, this carrier ring is used to connect T1s and T3s and other communication channels together. And think of it as a highway that cars can run over, so there's lots of on-ramps. Cars can be at the frame relay, ATM, X25, and many other types. And basically, SONET is still used today and connecting to a lot of networks over ATM. Okay, WAN Technologies. Common ones are going to be your dedicated lines, ISDN, DSL. You have your frame relay, cable, X25, SMDS, ATM, and VoIP. Okay, these numbers you pretty much just have to memorize. How many people have dealt with T1s and T3s in the past? It's one that if you have not dealt in networking, there's a good possibility that it's going to be less and less likely that you have. T1s and T3s are becoming less and less common. A lot of people go into the fiber now because it's just a lot more. I mean, especially with a lot of the compression schemes that they're working on, basically makes it to where some of the fiber that was put in there with the concentrators, 10, 15, or I guess 10 years ago or so, aren't going to be able to hold nearly as much as the same fiber line with different equipment's going to be able to hold. For example, with the T1, that used to be relatively common for large organizations, and now T3 can barely hold the data put. How many pairs are going to be in a T1? Yeah, pairs as far as cable or wires. Kind of like on a Cat 5, you're going to have your 4-pair. Close. It'd be the 25, and then the one's basically for the administrative. So yeah, you're going to have your 25 pair, and then each one has their own same color code as the regular one, except it would be, instead of solid, it would be striped as well. And there's like purple and some fun colors. Yeah. Okay, PSTN, Public Switched Telephone Network. Basically a collection of interconnected systems operated by different telephone companies. There's the POTS, which is plain old telephone system. It's also all digital, except the final connection to the subscriber line, or last mile. Does anybody understand what last mile means? Okay, last mile is basically the courier is going to bring it all the way up to the company's DMARC.
No, I was going to say until the last part, until it reaches the end user.
Usually it's not even the end user when it comes to it's, for example, if somebody owns the entire infrastructure from the outside, they will have everything up to the last mile, and that will be sometimes the last mile is sold to you by a secondary company as well. So you may have, for example, a major telco and then a local telco, and basically pay both of them. But the last mile is usually from the central office or from the main CO to the DMARC at the individual's location. This is a big issue with disaster recovery and business continuity planning, because a lot of people will get two different vendors and not realize the two different vendors are using the same last mile. Because that happens a lot in rural areas, is because there's just, they didn't build the infrastructure properly. Or they did build it, but it wasn't for as many people that were in the area. Okay, there's also signals from telephones are analog, converted to digital signals at the CO, their central office. Several data streams are then multiplexed into 24 channels of a T1 line. And then these 24 channels can then be further multiplexed into core trunks. Okay, ISDN characteristics. You're moving the last mile from an analog digital transmission. Provides high data transmission over existing telephone lines, so you get a little bit more speed into it. And does anybody remember the, what was it, the, not FAA, but the FCC regulations for maximum speed on modem lines? So you had your 56-bit modems, or 56K modems? Yeah, it was like 52. Yeah, there was 14, then it went up to 28, 36, and then you had the 56K modems, but you couldn't quite get there. I believe it was like 52. Yeah. That's one of the things that with ISDN, you got even a little bit more as well. So you can even do multiple channels, and you get up to 128. So that was real fast back then. Yeah. Oh, Commodore was a great thing. One of the few computers that actually hooked up to a TV, so you didn't have to get a proprietary computer monitor. That was, I guess, a great thing for the computer industry, but requiring that extra hardware.
That's still like the acoustic coupling.
Okay, ISDN uses the bearer channel to move data in a single D channel for connecting setup and teardown. So definitely know the difference between the D channel and the bearer channel. And if the main service goes down, they can still communicate through the ISDN channel. The DSL, another technology that provides digital solution for the last mile. This works at the high frequency rate. So you still get to see your good old tip and ring lines, or copper lines, but it's going to be at a higher frequency than your basic voice. So even though that your voice is going over the line, it's also going on the line, and it's supposed to be spliced out at either the PED or within the DMARC within the organization's building or whatnot. Again, you're looking at, this is why some of them you can only do 2.5 miles or less. I know that a lot of organizations are trying to make it to where your DSL line, you can get a little bit further, but if you were closer to the POP, you could get a lot faster bandwidth. So instead of your, let's say, 7 meg, they were trying to push 10 and 15 meg downloads, which by doing that, you're basically, a lot of them were using the same infrastructure, same equipment. They were just pushing more power down the lines, which is going to cause potentially more data damage and more other challenging issues. Okay, also referred to as an always-on technology. Because once you get to this aspect, especially cable modems, DSL, and some of the faster technologies, people just don't shut off their systems. Unlike the modems, which people, whenever they connected, it was relatively good dial-in service if you had, I believe it was an 8-to-1 ratio, which means that you have one modem for every 8 users. With this type of scenario with DSL, you pretty much have to have enough bandwidth for everybody to be connected at one specific time, or else you're not going to be able to sell. Okay, cable modem. Characteristics of a subscriber cable company has an extra frequencies. Then the proper equipment they provide for the cable TV and internet access can be used for both types of communications. There are security issues. Basically, if a neighbor is sniffing each other's traffic, they have fixed this in a lot of areas, but the challenge is if you can find the older modem, because the way they fixed this in most areas is they upgraded the firmware so you can no longer do promiscuous sniffing through your network. So if you downgrade the firmware or get one of the older modems, sometimes you can still sniff what's on those nodes or within those sections. So insecure users should implement personal firewalls. And cable modems convert RF to digital signal and vice versa, also referred to as an always-on technology. And how many people here have used good old satellite for the same thing? Some people can't get cable, they can't get ISDN, they can't get a T1, they can't get DSL because they're too far out in the boondocks or whatnot. Yeah. As long as you have a clear view of the southern sky, you can get some of the satellite companies. I've heard that they're really good as far as if you do your basic downloading and so forth, but I've actually had some issues during testing. There's like a 4-second delay or so whenever you do any sort of like telnet or other type of streaming communications back and forth. But if you start a basic download, then I hear the communications really quick. Okay, packet switching. You're going to cover X25 and good old frame relay. Okay, X25 characteristics. It's the first WAN packet switching technology developed on the internet, and it was mainly used for mainframes connected over telephone lines. It's considered a FAT protocol because it has much error detection and correction capabilities built into it. And this is basically was required when the internet was just telephone lines. And the main reason that was required is because sometimes the infrastructure was so old that it couldn't carry the signal, and there's a lot of basically bit shifts or bit drops. Today, this functionality isn't necessary because a lot of the lines are a lot cleaner. Okay, this has been built mainly to replace frame relay, or has been replaced by frame relay. Virtual circuits are set up between different points, and customers share and pay for the same network. Not much anymore, but still it's probably going to be on the CISSP. Yes. I've even heard stories about people using the X25 protocol over barbed wire fence because people kept stealing the copper in their geographic area when they're in different countries. Okay, frame relay. Characteristics. Fast WAN packet switching protocol because of its simple framing and lack of need for error correction. Basically, it uses PVC, which is permanent virtual circuit, which is path set up for 2 locations to communicate through, and path cannot be dynamically changed. There's also the switched virtual circuit, or SVC, which is dynamically built when requested by the customer, and then similar to making a telephone call. And also the CIR, committed information rate. Specific fee guarantees a specific bandwidth. ATM, the Asynchronous Transfer Mode, basically provides a high bandwidth of WAN Technologies, uses 53-byte fixed cells instead of varied length packets. Technology used basically for the internet's backbone, and equipment is expensive and rarely implemented in LAN environments. Multiplexing, basically data from different sources. Multiplexer receives data from different sources and then cuts the data up and then pushes it to where it needs to be in specific channels. Multiplexing is the process of combining 2 or more channels into one common transmission medium. VoIP, voice over IP. How many people deal with that or have worked with it in the past? Chances are you've used it at one point or another. I know a lot of the phone cards are actually using VoIP. So whenever you call into a 1-800 number and then put in the code, what it's doing is actually now transferring over VoIP to another portion of either the U.S. or outside the organization or country. So what was it?
Yeah, bondage.
Yeah, Vonage is a VoIP. There's Skype is a common VoIP. Technically, if you're using Yahoo or MSN-IM, if you're communicating over the audio there, that's VoIP as well. But very common to have a lot of these digital phones and then have VoIP systems. And a lot of people, when they first came out, these VoIP networks or VoIP PBXs or whatnot, they put them on the same network. So packet sniffing was relatively easy. So the best thing you should probably do is segregate the networks or separate them to where one's going to be on a specific area and then one's on a separate network or separate physical hardware as well.
So you should keep it off your domain.
Yeah, you should keep it off the same network the rest of your computers are running on. For the main reason is you're allowing people to now sniff or disrupt the voice. Yeah, VLANs are great.
One goes down, you don't really want the other one necessarily.
Yeah, and that's the other thing as far as protection, because there are a lot of times when your network goes down, specific devices go down.
We'd like to be able to call the provider.
Yes. That's a very important thing.
Without having to use your blanket.
Yeah. PBXs, private branch exchange. PBXs are telephone switches that reside at a customer's property. Usually a T1 or a T3 connects the switch to the provider's CO and uses for calls between internal lines and PSTNs, or public switch telephone networks. These are still out there, and you'll also see a lot of VoIP PBXs as well. How many people here have seen Asterisk before? This is an open source phone system or VoIP phone system. You can actually hook it up to systems to where you can make SIP calls and then connect it directly to a LAN system. Whenever anybody's talking about like a landline, that's usually referring directly to the tip and ring line. So you can hook up the Asterisk PBX from a piece of software or another piece of hardware running a SIP, RS-232 or H.232, protocol, and then make outgoing phone calls. A lot of the PBX out there, how many people here have heard of phreaking? Phreaking, which is phone hacking. For example, there was a Phreak, which was a magazine that was basically built from a bunch of phone phreakers, and then it got into the networking side as well. Because how many people here have heard of smashing the stack for fun and profit? That, I believe, was Phreak, was it 43 or issue 43? So it was way after it first started. There was also 2600. How many people know why 2600 is called that? 2600 is basically the frequency that is made for a lot of the phone systems. Then there's also the good old Captain Crunch whistle that supposedly made that frequency as well for making phone calls. But a lot of the phreaking organizations will have basically handbooks or default usernames and passwords for a lot of the PBX systems. Not only for your regular phone systems, but a lot of the voice ones as well. So a lot of the people that were working in the telcos do change it by default and have their company password. But with that being said, is if you've ever worked within a specific phone company, you're now going to know the default. So if you ever leave, you can usually hack into almost anybody's phone system that's been set up by that organization. But a lot of the scenarios, PBXs or the VoIP systems, will have default, say, extensions. A lot of organizations will have, for example, the default extension is, let's say, 1073, and that's going to go up to the intercom. So if people know that, and a lot of the phone phreakers actually store this type of information when they find it, they know that whenever they call an organization, they try to get past the gatekeeper. For example, as you go to your favorite retail store. You call the retail store and then get into, let's say, the automotive department. Once you get into the automotive department, you get asked to transfer to the sporting goods. A lot of times what the people do is they'll instantly transfer you over, but they won't force your outside line to be shown during the transfer. They'll just transfer through their line. So it looks like it's coming from within the organization. And then what you do from the attacker side is going to say that, yes, once you get the sporting goods, I actually work in automotive. Which, I actually didn't mean to dial your extension. Would you please transfer me to this extension? Which would either A, be some sort of command that you want them to type in on the phone to either open up a voicemail or whatnot, or even transfer you to the intercom. And then what you're doing is trying to do social engineer, because they see you coming from automotive or within the company. You get bounced to the actual extension. It is potentially dangerous. which is either going to be the internal tech support or potentially even the intercom. Then you can have a havoc on it. Yeah. Blue light special. Okay, vulnerabilities for this. Potential issues. These are not usually included in security assessments. A lot of them, however, are still on the network. They do have live IPs because a lot of people want to get information from it, such as how many calls were made that week, that month, how long specific individuals were on the calls as well. There's compromising and reconfiguring telephone switch by hackers, such as breaking in and leaving back doors, and attackers obtaining free long-distance services. I had a colleague that worked in an organization where that's what happened, is that they got this extremely large phone bill. This was in the hundreds of thousands of dollars phone bill. And what ended up happening was somebody, I guess, got into somebody's voicemail and happened to know the default to exit out of the voicemail. They ended up hijacking a trunk line and then bouncing out of that organization, called a number in Africa, bounced it up to Europe, then bounced it back into the States, and then started selling that access through a 1-800 service as phone cards. So they made it to where probably made a lot of money out of it. And what was that?
They ever catch them?
No. But they did close the close the hole. They changed the count. Yeah.
I heard that happening in college where somebody figured out how to call some company in West Virginia,
Mm-hmm.
be able to dial out of their long distance.
And that's the thing, is like a lot of the voicemails, sometimes you can do specific key sequences and then pop right out of the voicemail and either go into the administrative portion of that account or into your basic administrative admin interface to that PBX system. And that's what a lot of the phone phreakers will have, is the default settings, for example, like the Nortel, the Mitel, even the Cisco systems.
And at that point, even if it does on the bill show what extension it's coming from, it doesn't know because of the way it
Yeah.
the voicemail first.
Yep. So once you get into that area, and then you jump out, now you're actually connected to that account or to that voicemail. So.
And the voicemail a whole nother number.
So yeah, when people have the PBXs, that's definitely a challenge. And then again, phreakers, hackers who specialize in telephone fraud. Then again, there's the good old red box. How many people remember that? The red box was where you grab this tone dialer. Basically, you could get one from your friendly Radio Shack. And when you get the tone dialer, they had a specific crystal in it. So whenever you dialed the 1, 2, 3, 4, 5, 6, 7, 8, 9, it actually also had a memory button, so you could store up, I think it was like 99 phone numbers. Well, it made the same tone as if you actually pushed the button on the phone. So basically, if the phone was broken, or if you just didn't want to touch the receiver on the phone, or you didn't want to memorize the 10 digits of the phone number, you just wanted to memorize the 2 digits for the 99 numbers that it's holding, you basically hit the memory, the number, and then it dials for you. If you wanted to do telecommunications fraud, this worked until about early 2000. You can get one of these tone dialers and take the main crystal out and replace it with, I believe it was a 5.536 megahertz crystal. And then whenever you pushed a specific number, it made a sound that the quarter would make when it was dropping into the machine. Same thing with a nickel and a dime. So you could go through and make long distance phone calls for free. Well, one of the things that the phone companies started doing was saying, okay, people are doing this. We really know this is a bad thing. So what we're going to do is make it to where there's a little lever, and the microphone's not going to turn on until coinage has been dropped into the phone. So then you made it to where you can drop a nickel into it, and then it hit the lever, and then the microphone turned on, and then you can start making the sound again. And the reason why it was like that was because way back in the day, they had the payphones where people were actually listening into the phone and doing the transfer, and then making sure that the coin was being pushed in. So they had to listen for those tones or for those sounds. And then that technology just never got replaced whenever the people got replaced by technology. So it was the funny scenario was until, what was it, about 3 or 4 years ago, a lot of those phones, they tried to upgrade to where it would work until you put a nickel in it, were still vulnerable for it. And people were making thousands of dollars of phone calls for free or for a nickel.
The reason they started taking the phones out, get ready to go to cell phone.
Yeah.
There was a hack too when you had the payphones when the Bell wrapped cord from the take a paper clip, you touch it to, like you put it through the hole in the speaker, you touch it to the metal wire, and it bypasses dropping the quarter in.
Yeah.
And then you dial the number, with it connected, you dial the number, let it go, and it's like at least 3 local calls.
Yeah.
I don't think it works for long distance.
And then they also had a few others to where, because basically what ends up happening is when you make a phone call, there's a voltage change whenever the other receiver picks up. I know people were trying to make it to where they were playing around with the voltage on the phones that were coming or incoming calls and making it to where it didn't sound like the receivers actually picked up, even though the circuit was actually full. So they were trying to, they were committing telecommunications fraud on their own systems when people were sending like collect calls. So that's another reason why a lot of the operators had to stay online and validate that you did receive it and it's being pushed forward. So I know this domain was going the wrong direction. I know this domain was relatively big, and this is another one which I do hate to say it. A lot of the stuff is memorization. For example, like the what does WEP stand for? What does WEP stand for? For wireless? Privacy. A wireless or wired equivalent privacy. As long as you memorize the word privacy in there, you're going to do very well.
You did mention that a lot of times they'll spell out stuff in the questions.
Usually they should.
You don't see the acronyms so much.
Usually, except for something like WEP. They may throw in a curveball and say, what does WEP stand for? And give you these 4 options. And I know so many people go through and accidentally choose protocol as opposed to privacy, because that's just a common thing to push.